Okay, number 2 asks us to verify, which means we're doing proof. Show the quadrilateral WXYZ with the given vertices as a parallelogram. I've already sketched it, and you should sketch it as well. And now what we need to do is use one of the properties of a parallelogram to show that it is a parallelogram. What I chose to do was to take the distances, and I'm basically, what I did is I'm proving that this is congruent to this, and that these two are congruent. So I'm just doing that real systematically using the distance formula, and I'm marked with subscripts the dimensions that I'm finding first. So for example, dxy, that's this one right here that we're looking at from here to here. I did that one first, okay, using the distance formula, and then the next one I'm going to do is the distance of ZW, okay, and then those two should match, right? Okay, then I'm going to do the ones that are more vertical, which is the distance of YZ, and then the distance of XW. And if I can show that these two are congruent and the top two that I have here are congruent, then I'm going to be good. All right? So XY, we're going to take the X values, 5 minus 0, and square it, which is 5 squared. And then I've got -1 minus 2, which is -3 squared. So if we finish that, that gives me 25 plus 9, which is the square root of 34. All right? Next thing I want to do is ZW. So I can take 4 minus -1, which is going to give me 4 plus 1 squared. And then I can take -9 minus -6, which is -9 plus 6, square that, and do the math on that one. That gives me 5 squared plus -3 squared, right? So I'm thinking you can see pretty quickly that this is the square root of 34 as well. So these two check out. Okay, well, let's see what we get for the other two. For YZ, we take 0 minus -1. That gives us 0 plus 1, so that's 1 squared. And then for the next one, we can say 2 minus -6, which is like 2 plus 6 squared. So that gives us 2 plus 6 is 8. 8 squared is 64. 64 plus 1 squared is 65. So there we have the square root of 65. Let's see what we get when we find the dimensions, or the length, the distance from X to W. I'm going to say 5 minus 4 is 1 squared, all right? And then we have -1 minus -9, which is going to be -1 plus 9 squared, right? Can you see all of that? And so then that gives us 1 squared plus 8 squared, which is the same thing we had here, which is 65. So that checks out. So we've proved that this is a parallelogram.